Hi, my name is Xingsheng Chu from Civil and Environmental Engineering. This summer, I'm doing research with Professor Raskin and her research group on a project, biological removal of arsenic and nitrate from drinking water resource. Nitrate and arsenic are worldwide problems of drinking water contamination, especially in the developing countries in Asia. The maximum contaminant level of arsenic regulated by EPA is 10 mg per liter. However, according to the World Health Organization, over 65% of the tube wells in Bangladesh have the arsenic level of over 100 mg per liter, which is 10 times of the EPA regulation. Long-term exposure to arsenic could lead to skin lesion, as shown in the picture, circulation system disorder, and increased risk of cancer. Long-term exposure to nitrate could bring negative health issues to the infants, which is called the blue baby syndrome. Problems with current arsenic and nitrate removal are that both nitrate and arsenic could leach back into the soil and water after landfill. Besides, the removal process could be very expensive. Usually, nitrate is removed from water by biological denitrification. This process reduces oxidized forms of nitrogen as the electron acceptor in the order of nitrate, nitride, nitric oxide, nitrous oxide to the ultimate product, nitrogen gas. Arsenic is usually removed from water resource with the help of microorganisms. At first, iron 3 is turned to iron 2, arsenate is turned to arsenite, and sulfate is reduced to sulfide by the microorganisms. Sulfide could form arsenic sulfide and iron sulfide with arsenite and iron 2. And arsenite sorption could happen along with iron sulfide. Both these wastes are stable for landfill. So here are the two reactors of our project, the continuous flow reactor and the household reactor. The continuous flow reactor is generally a model for the water contamination removal system for the community use. It contains two identical columns filled with granular activate carbon. Acetate and iron are loaded in the syringe and fed to the reactor with other influent. As we can see from here, the blue points are the arsenic concentration and orange points are the nitrate concentration of different parts along the flow path. Nitrate is completely removed in the continuous flow reactor, and the arsenic concentration is decreased from around 200 microgram per liter to 50 microgram per liter at effluent part. The household reactor is basically a bucket with layers of sand and gravel. It's a point-of-use system with lower cost and easier operation. Similar to the continuous flow reactor, nitrate is completely removed and arsenic concentration is decreased from 200 microgram per liter to around 75 microgram per liter at the effluent part. As for my own summer research experience, I got a chance to hands-on to do the inductively coupled plasma mass spectrometry, ion chromatography, total carbon measurement and method development, data analysis, and standard and influent preparation. Inductively coupled plasma mass spectrometry is highly sensitive and capable of determination of a range of metals. It is based on coupling together inductively coupled plasma as a method of producing ions with a mass spectrometer as a method of separating and detecting the ions. In our project, ICP-MS is used to determine the concentration of arsenic in iron. Ion chromatography is a form of liquid chromatography. Ionic species separate differently depending on the species size and type. Sample solutions pass through a precious columns, where ions are absorbed by the column constituents. The retention time differs from different species, and thus determine the concentration in the sample. We use the IC to measure the acetate, chloride, nitrate, and sulfate concentration of our samples from different parts of our reactors. Total organic carbon is usually used as the indicator of water quality. It is measured by the TOZ analyzer. It measures the amount of inorganic carbon evolved from an acidified part of the sample and the amount of total carbon presented. Total organic carbon is calculated by the subtraction of inorganic value from the total carbon. During my research, I was able to lower the detection limit of TOC analyzer from 10 mg per liter to 0.08 mg per liter by increasing the injection volume and number of injections. Well, that's all for my summer research experience that I would like to share with you guys. I would like to thank the University of Michigan and the SHIELD program for providing such a good opportunity to assessing my research potential and interest, which is really important for my future career. I would also like to thank Professor Ruskin, Professor Hayes, Gila, Tara, Alyssa, Katie, and Nadine. Thank you all for this great summer research experience.